Okay, hi everyone. This video is for my calculus students, and in this video I'm going to show you how to evaluate limits. It's like an introductory video, how to evaluate limits using the algebraic methods. Guys, I strongly believe that it's important for every calculus student to know how to evaluate limits using tables and how to evaluate limits from graphs. So I want to make sure and I want to let you know that you guys should practice evaluating limits from tables. You should practice evaluating limits from graphs, and then once you are done with that, then you should move on, and we want to know how to evaluate these limits using algebraic methods. Now here there are so many different types possible. So what I'm going to do is as a student, when I was a student myself, what really helped me was seeing many different types of examples. So I'm going to try to show you as many examples that I can, and I'm going to try to show you different types of examples. I'm not going to show you just the same example or same type of example over and over again. Well, there is going to be some similarities, but I'm going to try and show you many different types. So let us start with just some basic key things, and then we're going to use those key things and some other information that we have learned prior, like in pre-calc and algebra, and we're going to try to bring it all together and eventually evaluate the limit. Okay, guys, keep in mind here I'm not trying to define what a limit is. I expect you to already know all that. I'm just going to actually do these examples, and kind of while we do these examples, probably briefly go over some of the key things. Okay, so without further ado, let's go ahead and start with just some limit properties. So the three properties that I would like to recall here is the first one, the limit as x approaches to, let's say, a of a constant. So limit of a constant is always a constant, okay? So it does not change. Whether x approaches to a or b or whatever, it's always going to be a constant as long as c is constant. The second one is limit of x as x approaches to a is simply going to be a. So you're basically just kind of substituting x equal to a, but keep in mind evaluating a limit is not exactly evaluating the function at that point. It is evaluating the function, or basically trying to know what is actually happening very, very, very close to that point, not exactly at that point. And most of the times what is happening in the neighborhood of a point is exactly what is happening at that point. Okay, but there are special cases where the point may have a specific value at that function, but in the neighborhood it may be completely different. So while we look at these examples, and as you look at go through the calculus course, you will see a lot of those examples as well. Okay, so that is the second one. And then the third one is basically for any polynomial function of the form x to the power n, the limit can be evaluated just by simply substituting x equal to a, so it becomes a to the power n. So this basically is a consequence of number 3. Okay, so let us keep these three in mind, and using these three, let's go ahead and now try to do some examples. The first example is we want to evaluate the limit as x approaches to 2 of a quadratic polynomial 3x squared minus 5x plus 4. So you can break it down into 3 pieces if you like, and then apply limit, or you can simply realize the fact that this kind of is a combination of this as well as a constant, because there is a polynomial, there's an x term, there's x squared, there's x, which basically is kind of this form, and then there's a constant 4. So what you can simply do is, based on what you see here as the basic properties, you can just simply substitute x equal to 2, x equal to 2, and for 4 you cannot substitute anything, you just leave it as 4. So it's going to look like 3 times 2 squared minus 5 times 2 plus 4. So it is 2 squared is 4, 4 times 3 is 12, minus 10 plus 4, which is going to be 6. So we know this is a simple quadratic function. There's nothing crazy happening here. So as x approaches to 2 from the left hand side as well as from the right hand side, it's just going to behave nicely, and you are going to just be able to actually evaluate the limit just by actually evaluating the function at that point. Okay, so it's simple. Let's move on. Example 2. For example 2, I have a quotient. So I have x approaches to 3 and x cubed minus 5x plus 4 divided by x squared minus 2. In order to do that, what we can simply do is we can basically put the limit to the numerator and the limit to the denominator. The only thing that you have to be careful here is that when you evaluate the limit in the denominator, in this case, which is limit x approaches to 3 of x squared minus 2, we want to make sure that we are not getting a 0 in the denominator, because one, we cannot divide by 0. Second, if we have a 0 in this case, then it's going to be slightly different. Then we have to handle it in a different way. We may have to actually look at the graph of that function, and from that we may have to look at the left hand limit and right hand limit to eventually come to a conclusion what is the limit and if it exists or if it does not exist. So in this case, we can quickly actually do that without even like writing all the steps. So if x is 3, so 3 squared is 9, 9 minus 2 is 7, so we're fine, it's not 0. So if it is not 0, let's go ahead and just simply evaluate this function basically at x equal to 3. Okay, there's a quotient function, but it's still a nice function, nothing really crazy going on here. So you simply write it as limit x approaches to 3 of the numerator. I would write that step and then limit divided by the limit of the, we can put it in parentheses. Okay. So let's go ahead and actually evaluate the limit. I mean, this is still a combination of a variable and some constants, which is similar to using 3 and number 1, and same thing with the denominator. Okay, so 3 cubes minus 5 times 3 plus 4 divided by 3 squared. Guys, keep in mind, as long as the function is behaving nicely and it's a simple function, simple enough function. I mean, it's not a very simple function. I mean, this is simpler than this, but as long as the function is behaving nice, it's basically evaluating limit is just basically evaluating the function. As soon as the functions start to get tricky, then one has to be careful. Then one has to be very careful, and one has to make sure that one does not confuse with evaluating the function, which is just evaluating the function at a particular point, and evaluating a limit, which in that case is more like what happens and what is going on in the function in the neighborhood of that point. Okay, so in this case, let's quickly simplify this. 3 cubes says 3 times 3 is 9 times 3 is 27 minus 15 plus 4. 3 squared is 9 minus 2. When we simplify this, 27 minus 15 is going to be 12. 12 plus 4 is 16. 16 over 7. So 16 over 7 is the limit. So as x approaches to 3, this function approaches to 16 over 7. And if you like, or you want to verify things, you can always go ahead and try to graph this function, and then using a TI-84, 85, whatever you have, and then from that you can actually see that this function is probably going to get closer to 16 over 7, or probably going to be, in this case, exactly 16 over 7. Okay, so this is basically type 1, type 2, some of the properties, some of the key properties. In the next video, I'm going to talk about some more examples. Guys, as I already mentioned, there's a lot of different types. So I'm not going to try to do this in one video, so we're going to break it into different videos. Okay, so in the next video, I'm going to do some other types.